All right. I want to show you guys how to use something on your calculator. So we finished our 4-step process yesterday. We got all the way to writing our conclusion. Another class did this same activity, and they had these results. Their x-bar was 97.9. Their standard deviation, SX, was 1.6, and they had 30 in their class that participated. I want to know, should they reject or fail to reject at the 0.10 alpha level? So you guys are going to need to do the do step and find the p-value for x-bar of 97.9 with a standard deviation of 1.6. So you need to find the p-value with these results, where x-bar is 97.9, SX is 1.6, and N is 30. We're going to use something called t-test on the calculator. So you guys are going to need your graphing calculators. If you need to borrow one from me, please come grab one off the desk. So I want to show you where the t-test is. We're going to go to stat. We're going to arrow over to where it says tests. So stat, and then arrow over to test. What kind of a test are we going to do? T-test. So I want option number 2. We're going to enter statistics. So we want this option here, and you have to hit enter because it needs to be shaded around where it says stats. What are we using for mu, our null hypothesis? 98.6. What is our x-bar? 97.9. SX? You said 1.6. And N? 30. Do we want to do not equal to, less than, or greater than? Not equal to. And then we want to calculate this. What is our p-value? That is. If it's a multiple choice question, I would recommend using this. If it's a free response question, you can use this to double check your answers, but you still want to show your work. But yes, you can do t-tests and z-tests on the calculator much, much faster than doing it by hand on the multiple choice, and you can always use it to double check your work on a free response question. But you have to show your work on the free response or you don't get full credit there. What is our p-value? 0.0232. All right. So we know our p-value now. Would we reject or fail to reject at the 0.10, alpha equals 0.10? Reject. So we are going to reject it because 0.0232 is less than 0.10. What about at the alpha equals 0.05 level? Reject or fail to reject? Reject. So are we going to reject it? Yes, we are. Because again, 0.0232 is less than 0.05. What about at the alpha equals 0.01 level? Fail to reject. Because 0.0232 is greater than 0.01. So we reject at the 0.10, we reject at the 0.05, we fail to reject at the 0.01 level. Now I want you guys to use the t interval. It's still stat calculate. So stat, arrow over to calc. I don't want t-test this time. What do I want? What did it ask us to do on here? T intervals. So we're going to do option number 8, T interval. Because remember, all we have is the statistics. We're going to enter the statistics here. Confidence level. What do we want confidence level for the first one? 0.9. And then we're going to calculate. And it's going to show me my interval. What is our interval? Our interval is 97.404 to 98.396. So would we reject or fail to reject? Reject, because why?
98.6 is not in the interval.
Yes, 98.6 is not in the interval. I want you guys to do the same thing at the 95% and 99%. Decide whether we're going to reject or fail to reject the null hypothesis. Take about a minute and a half.
Was there a problem with the video from yesterday?
Did it not post?
I didn't see it.
I will double check. It should have gone up, but I'll double check if something happened.
So I have like this line through my calculator,
Lovely.
and it's been like that for like a couple of weeks, but I keep forgetting to say anything.
All right, trade me.
Okay.
What is our confidence interval at 95%? 97.303 to 98.497. So reject or fail to reject? Reject, because 98.6 is not in the interval. What about the 99% confidence interval? 97.095 to 98.705. Reject or fail to reject? Fail to reject, because the interval contains 98.6 finally. Remember, as our confidence level goes up, our interval becomes wider. So what do you notice between the answers that we had up here when we were using the alpha levels and doing hypothesis tests versus when we did our intervals? They're the same. Were we doing less than, greater than, or not equal to here? Not equal to. The decision of whether or not to reject the null hypothesis is the same as using either a confidence interval or a two-sided significance test. So the alternative is mu is not equal to. If we're doing a greater than or a less than, we wouldn't necessarily have the same like one-to-one comparison here. So if you're doing less than, you're just looking at one side of it. Our decision to reject or fail to reject is exactly the same when we do a confidence interval or when we do a two-tailed, a two-sided significance test, a not equal to significance test. So there's been a few takeaways from this. One, all of that's written there in black about our two-tailed versus our confidence interval. But you guys have also now learned some shortcuts on your calculators. T-test you can do on the calculator. t-interval you can do on the calculator. Z-test and z-interval you can do on the calculator. Absolutely would go that route if it's a multiple choice question. They don't care about your work at all, and that's a very fast way to answer confidence interval questions or significance test questions. If you have the statistics or if you have the data, because you can enter the data in lists 1 and 2 and whatever if you need to, and then you can use that data to run your test as well. Well, you have to know how to do it by hand. But it is nice to have a shortcut, a way to double check yourself when you get to the free response questions. Just in case you make a mistake somewhere in the calculations, you can go in and check. What they care about seeing is that you've substituted the things into the formula, and then you have your test statistic. So you could even use the calculator for that. Write all the numbers into the formula, and then use t-test or t-interval to come up with those other pieces. All right, so big takeaways from what we did yesterday. 4-step process, state, plan, do, conclude. In state, you have to have your parameter, hypothesis, and alpha level. It is helpful to write down your statistics there so that you've got them in one spot because you're going to need those for the do step. If you don't have them in the state step, I'm not going to take off points, but it's a good idea to write those down right at the beginning. Plan, you have to name your procedure. If you don't name the procedure, it is definitely not going to be full credit. You won't get an E. You have to say whether you're doing an interval or a test and which one. Is it a Z or a T? You have to check your conditions, random, independence, 10%, normal, large counts. General specific work, test statistic, p-value, and a picture, things that you absolutely must have to get an E. You have to have the specific with your work. You have to have the test statistic and the p-value, and you have to have your picture. If you don't put the general formula or the specific with the symbols in it, that's fine. But you have to show substituting into the formula. You've already set up here what the name of your procedure is. If you don't say the name of the procedure, then you absolutely have to have the specific formula with like T equals X bar minus mu, because that is also showing what test you're using. So if you don't remember to put the name of the test, you have to put the specific formula that you're using there. And then conclude, you interpret your p-value, and you make your decision and conclusion about your alternative hypothesis. Confidence intervals and two-sided tests. If the null value is in the interval, then the HO value is a plausible value. You would fail to reject. If the null value is not in the interval, HO value is not plausible, and you reject HO. A C% confidence interval will make the same decision as a two-sided significance test with alpha equals 1 minus your confidence level. I'm going to give just a couple of minutes for you guys to check your understanding. It is fairly short. Let's see if we can get through those 2 questions in about 5 minutes. It posted. It should be up on YouTube. Monday, 2/26. Should be towards the top, but I don't know. Sometimes settings get messed up, and it'll like alphabetize them instead of putting them in order by date.
I saw the geometry one, but I couldn't find ours. So I was like, okay.
So yours, I actually had to wait on that one. Didn't go up until about 5 o'clock yesterday because it took a while to render. So if you checked before 5, it wasn't up yet.
conclusion, like an interval, or like a test?
No, I just want to know like what your conclusion would be. Would you reject or fail to reject? You don't have to write out the whole conclusion, but say whether you would reject or fail to reject and what your reasoning is for it. What would an appropriate parameter be? Like, how would we define our parameter here? Ben?
The actual average flight time.
A little bit more, and I wouldn't use actual, I would use true. That's the thing that they keep going after, because we want to find, like, what is the actual truth here? That's what we're using it to estimate.
True average flight time of all things differing from the average advertised 32 hours.
We don't want to know about the ones that are different. We want to know the true for all of them. So the true mean flight time or the true average flight time of all 18-inch helium balloons from this company, because we only pulled our sample from this company's balloons. What would an appropriate null hypothesis be?
H of plus mu equals 30.
30? 32.
32.
Yep, because it says the advertised flight time is 32 hours. So that's their claim. And then our alternative hypothesis would be mu does not equal 32. Yes. All right, so we don't have to calculate the 95% confidence interval. They did it for us already. And that interval was 28.5 to 31.4. Based on that interval, would you reject or fail to reject? Reject, because? Yep. 32 is not contained in the 95% confidence interval. So we would reject the null hypothesis at the alpha equals 0.05 level. We would find a p-value that is less than 0.05 if we were to do a significance test. So far, so good? All right. We're going to flip to the next page and keep going. For those of you that have already flipped over to the other page, I want you to find the mean for form A, find the mean for form B, and then subtract them. Yes. I don't have a toothpick, I'm really sorry. So on the next page, on page 8, I want you to calculate the mean for form A, the mean for form B, and then calculate the difference. So you can use your lists and have your calculator do X bar for these.
So I'm just trying to show, like, I can do form A in this one and form B in this two, or whatever.
Yep.
I'll say, or to make it more fun.
And then if you run 2 variable stats, it should give you X bar for each of those.
That's what I was wondering. I was like, is that something that compares them, and I just wasn't thinking.
Yeah, so it should just spit out both of those pieces on 2 variables. Should. If not, run 1 variable stats on L1 and then run 1 variable stats on L2 if for some reason it spits it out wrong. Oh, do you need me to go back? There you go. I'm going to send around this green bowl. I want you guys to pick out one of the pieces of paper in here. You can open it, it doesn't matter, or not open it. We're not using it just yet, but I need everybody to have a piece of paper. So go ahead and grab one and then pass the bowl until everybody has a piece of paper. While the bowl is going around, does anybody have the mean score for Form A? 4.2. What about for Form B? 4, dead on. So what's the difference? 0.2. So these are the scores from East Kentwood High School last year. They did have 2 forms of the AP exam. Some years they do 2 forms, some years they do 1 form. I think more and more they're gearing it towards 2 forms. We're going to assume that these 2 forms have the same level of difficulty. That's what College Board claims. We are going to test that. So the idea is, if Doug scores a 5 on Form A, then he would have performed just as well on Form B. If he understands his statistics, it's not any more difficult on Form B than Form A. That's what we're going to start off by assuming. I want you guys now to take your little slips of paper. Because we're assuming that these 2 forms are the same, it shouldn't matter which form somebody gets. They should get the same score, right? So I took all the scores from these 2 boxes up here, Form A and Form B. I mixed them all up, and I randomly selected 15 of them to give to Form A and 15 to call Form B. Everybody has a different one because I randomly generated 30 of them. We don't even have 30 people in here. So everybody's got a slip. I want you now to do the exact same thing that you did for these 2 boxes, Form A and Form B, for your new values for Form A and Form B. This is randomized scores from the original test scores. Yes. Is it not showing you the other one? Should be Y bar for the other one.
Y bar?
Yeah.
Oh, that.
Yeah, it calls the statistics from list 1 X and the statistics from list 2 Y. You're welcome. So what I want you guys to do, you're going to do the exact same thing. You're going to calculate the mean for your Form A, the mean for your Form B, and then I want you to subtract and find the difference there. I'm going to go ahead and do 1 and 2. You got your paper, right? All right, so I've got mine. My X bar was 4.4 for Form A. And for Form B, I got 3.8. So now I need my difference. So my difference was much bigger. I got 0.60. I'm going to go around the room and get what your difference is, and we are going to plot these. So mine was a positive 0.6. I'm going to start over here. We're going to go down this way, then come back this way, then go over. So Anthony, what was your difference? 0.33, so about here. Negative 0.33. So over here, bless you. 0.33. Oops, sorry. It's super touch sensitive. What'd you get on it? Negative 0.7. B. 0.06. So 0.06, right about there-ish. What'd you get? Negative 0.46. Maya? Negative 0.36. Negative 0.36. Ben? Negative 0.03. So here-ish. Ty? 0.06. So another one right here. Sarah? You said 0.2? 0.2. Lacey? 4.2. 4.2? Did you do your subtraction?
Oh, 0.2.
0.2. There we go. Okay. It's like, woo, that's huge. Olivia? 0.2? Lainey? Negative 0.2? Estrella? 0.34. Brandon? Negative point what 6? Negative 0.06. So here. Logan? 0.2. And what'd you get, Morgan? 0.06. So right about here. All right, so go ahead and copy that into your notes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So N is 19. I'm going to write this down. There are 19 dots. What was the difference that East Kentwood had? Their difference was 0.2. So if I wanted to find out if these forms are different from each other, I would need to go two-tailed. So 0.2 was East Kentwood's result. What would the corresponding value be on the negative side so that I'm the same distance away from the mean? Negative 0.2, yep. So we'd be right here. Because remember, if the forms are not are exactly the same, what should the difference between these scores be? Nothing, should be 0. So mu1 minus mu2 should come out to be 0 if there is no difference between these two forms. So let's look at what we got. So how many dots are there that are less than or equal to negative 0.2 or greater than or equal to 0.2? How many on this side? 1, 2, 3, 4, 5, 6. Remember, we have to count the one that's exactly here because it's less than or equal to that. So 7 total. 7 dots over here. And on the other side, 0.2 or greater. I got another 7 dots over here. So a total of 14 out of 19 had results that were what East Kentwood got, that far away from the mean, or more extreme. What is 14 divided by 19?
.737 roughly.
0.737. All right. Let's see where we go from here. I'm going to put the dot plot back up in case you weren't done. There we go. East Kentwood had a difference of mean of 0.2. If we are assuming that both forms are the same difficulty, is that a surprising result? No. Because when we just randomly assigned these, we had how many that fell that far away from the mean? A lot. We had 14 total that fell that far away from the mean when we're including either side. So no. Assuming the two forms have the same difficulty, before I go any further, when I say assuming the two forms have the same difficulty, I'm saying that we're assuming the null hypothesis. The difference between mu1 and mu2 is 0. So assuming the two forms have the same difficulty, there is a 14 out of 19, or 0.737 probability of getting a difference of sample means of negative 0.2 or less, or 0.2 or greater, purely by chance. So this 0.737, that was assuming the two forms were even. They were the same level of difficulty. We obtained results that were 0.2 or more away from the mean 74% of the time. This is our p-value. Now, we did it through simulation instead of running the actual hypothesis test because we didn't have the standard deviation for these. But this is another way, just doing multiple simulations over and over where we get that sampling distribution. We can calculate the p-value this way. So based on that simulation, do we have convincing evidence that one form of the exam is harder? No. Because 737 is greater than what? What should we use for our alpha level? 0.05. We fail to reject the null hypothesis. And do or do not? And do not have convincing evidence that one form of the exam is harder. Why was it important that we did a two-tailed, a not equal to? Why didn't we only look at the positive side?
Because I can like basically like switch to.
What'd you say, Anthony? We're going to see if either one of them is harder. Positive would mean which form is harder. A. Negative would mean B is harder. That's why we looked on both sides. Now, East Kentwood results seemed to indicate that it was possible that form A was the hard, or was the easier form, sorry. because they had higher scores with Form A. I apologize. Lower scores with Form B, so that would indicate that it could have been harder. I think we said this backwards because I was thinking of it the wrong way. Higher scores would mean that the test would be easier if there was a difference between those two. Lower scores would mean the test is harder. We needed to check both sides because it could have been either form that was harder or easier. I'm going to stop right here so I have a chance to show you guys your tests from last week. What is due tomorrow? Homework number 1, 11-1. You'll pick up 11-2 tomorrow. That one will be due on Friday because we will be all the way done with this chapter by Friday. Test is next Wednesday.
Oh my